So question number 10 deals with the same image that was produced for question number 9, where it says an electron is placed at the 100-volt mark, described as question 9, released from rest and would accelerate towards the higher potential of 200 volts. What speed would it acquire by the time it reached the 200-volt surface? If a proton was released from 200-volt surface, it would accelerate toward the lower potential. What speed would it reach at 100 volts? So basically, we're saying an electron's starting here and flowing path 1. A proton's going to follow path 1, but in the opposite direction. And how fast would they be traveling at either position? So let's do the electron first. And we're going to have 100 volts and then 200 volts. And we're going to have an electron right here. Now, again, if we think about this, we're going to think about, well, there's this positively charged object here. The closer we get to that object, the higher the electric potential, the farther away, the lower. So 100 and 200 make sense. And yeah, this is going to make sense. An electron's going to naturally move in this direction towards the 200 volt. So we go from high potential energy to a low potential energy. And so what that means is we're going to gain kinetic energy. And we're gaining kinetic energy because the electric field is doing work to accelerate this electron. So we can use the equation of electric potential difference equals the amount of work divided by Q. And again, the idea is that the work is going to be the gain in kinetic energy. So it's going to be energy kinetic over Q. And so we can then say energy kinetic equals electric potential times the charge. Now, we've learned in the past that kinetic energy is simply 1/2 mv squared. And if we look at this, we're just trying to find what speed would it acquire, right? So we're trying to find that velocity in this equation. So plugging in then 1/2 mv squared is equal to electric potential times charge. And then we're going to solve for velocity. So I'm going to end up with velocity equals 2 times my electric potential times my charge divided by my mass, square root. When I plug those values in then, I'm going to get a velocity of 5.93 times 10 to the 6 meters per second. And that's the velocity that the electron would be traveling. For the second part of the question then, we're going to have a very similar setup for B. But now we're going to have our 100 volts and 200 volts, and our positively charged proton is going to be here. And again, it's going to naturally want to move in that direction. This is a high potential energy. This is a lower potential energy. And so again, what we have is we have some gain in kinetic energy, and that gain of kinetic energy is due to the work done by the electric field. The electric field is applying a force in this direction. It's moving obviously some distance s, and so that work is being done there. So we're going to use the same equation, that was produced right here, where our velocity equals 2 electric potential difference Q over mass, square root. Now, in this case, you might be careful because this would actually produce, a 100 minus 200. This would produce a negative, but we're just looking for the value here. And so the negative would be like a loss of potential, but a positive would be a gain in kinetic, okay? So you just got to be careful with the negative here. We obviously can't square root a negative, but we don't really need the negative here because we're just looking for the value, right? The loss of potential is the gain of kinetic, so that negative really goes away there. In this case, the main difference, the charge is going to be the same, electric potential difference is going to be the same. The main difference is going to be my mass. Where here we use the mass of an electron for part A. This one we're going to use the mass of a proton for part B. And so the velocity I'm going to get should be substantially less because I have a much bigger mass. So 1.38 times 10 to the 5th meters per second. And so we can see these velocities are much different. Even though the forces on these are the same, the distance they went on the same, the amount of work done is the same, this has a much slower velocity, this has a much higher velocity due to the substantial difference in the mass. And that's a common scenario that you're going to get when you're dealing with electric potential is, okay, we're going from potential energies, and if we're losing potential energy, we're going to gain kinetic, and hey, we need to be able to figure out how fast things are going, or if we're vice versa, if we were going from here to here, we're losing kinetic and we'd be gaining potential. Okay, so should be able to go from either one, but that's how we are going to relate the work and electric potential to the velocity that objects can travel.